morning, students. Welcome to Ich224 Polymer Chemistry 1. The contents of the course include Introduction to Polymer Chemistry, preparation of polymers, polymerization, catalysts, natural and synthetic polymers. What is polymerization? Any process in which relatively small molecules called monomers combine chemically to produce a very large chain-like or network molecule called a polymer. The monomer products may be all alike, or they may represent 2, 3, or more different compounds. Usually, at least 100 monomer molecules must be combined to make a product that has certain unique physical properties, such as elasticity, high tensile strength, or the ability to form fibers that differentiate polymers from substances composed of smaller and simpler molecules. Often, many thousands of monomer units are incorporated in a single molecule of a polymer. The formation of stable covalent chemical bonds between the monomers sets polymerization apart from other processes, such as crystallization, in which large number of molecules aggregate under the influence of weak intermolecular forces. What is a polymer? Any of a class of natural or synthetic substances composed of very large molecules called macromolecules that are multiples of simpler chemical units called monomers is a polymer. Polymers make up many of the materials in living organisms, including, for example, proteins, cellulose, and nucleic acids. Moreover, they constitute the basis of such minerals as diamond, quartz, and such man-made materials as concrete, glass, paper, plastics, and rubbers. The word polymer designates an unspecified number of monomer units. When the number of monomers is very large, the compound is sometimes called, when the number of monomers is very large, the compound is sometimes called a high polymer. Polymers are not restricted to monomers of the same chemical composition or molecular structures. Classes of polymers. Classifications based on polymerization process. 1, we have condensation polymerization. Each step of the process is accompanied by the formation of a molecule or some simple compound, often called water or hydrogen, sometimes other smaller molecule like hydrogen or ammonia, often accompanying the production of these polymers under condensation polymerization reaction. However, in addition polymerization, monomers react to form a polymer without the formation of byproducts. Usually, addition polymerizations are carried out in the presence of catalysts, which in certain cases exert control over structural details that have important effect on the properties of the polymer. Classification of polymers based on the source of availability. Here, there are 3 types of classification under this category, namely natural, synthetic, and semi-synthetic polymers. Natural polymers, they occur naturally and are found in plants and animals. For example, proteins, starch, cellulose, and rubber. To add up, We also have biodegradable polymers called biopolymers. I take that again. Natural polymers, they occur naturally and are found in plants and animals. For example, proteins, starch, cellulose, and rubber. To add up, we also have biodegradable polymers called biopolymers. The second one, we have semi-synthetic polymers. They are derived from naturally occurring polymers and undergo further chemical modification. For example, we have cellulose, nitrate, and cellulose acetate. The third one, we have synthetic polymers. These are human-made polymers. Plastic is the most common and widely used synthetic polymers. It is used in industries and various dairy products. For example, we have nylon 66, polyether, etc. Classification based on the structure of the monomer chain. This category has the following classifications. 1. Linear polymers. The structure of polymers containing long and straight chains falls into this category. Example, we have PVC, that is polyvinyl chloride. It's largely used for making pipes, and an electric cable is an example of a linear polymer. The second one, we have branched chain polymers. When linear chains of a polymer form branches, then such polymers are categorized as branched chain polymers. For example, we have low density polyethylene. Low density polyethylene are examples of branched chain polymers. And the third one, we have cross-linked polymers. They are composed of bifunctional and trifunctional monomers. They have a stronger covalent bond in comparison to other linear polymers. Bakelite and melamine are examples of cross-linked polymers. Classification based on molecular forces. Classification based on molecular forces. We have elastomers. These are rubber-like solids, and weak interaction forces are present in them. For example, rubber. Now the second one, we have fibers. Strong, tough, high tensile strength, and strong forces of interaction are present. For example, we have nylon 66. Thermoplastics. These have intermediate forces of attraction. For example, polyvinyl chloride. I said these have intermediate forces of attraction. For example, polyvinyl chloride, polyethylene, etc. Thermosetting polymers. These polymers greatly improve the material's mechanical properties. It provides enhanced chemical and heat resistance. For example, we have phenolics, epoxies, and silicones. Classification based on monomers. Classification based on monomers. We have 1, homomer. In this type, this is a mistake. We have homopolymer. This is homopolymer, not homomer, homopolymer. In this type, a single type of monomer unit is present. For example, polyethylene. Now, if you have the monomer, the single type of monomer that formed the polymer, Then the name of that polymer is called homopolymer. Then the second one, we have heteropolymer or copolymer. It consists of different types of monomer units. For example, nylon 666. Nylon 66. Sorry, let me take that again. Heteropolymer or copolymer. It consists of different types of monomer units. For example, nylon 66, dacron, etc. Classification on the basis of the type of backbone chain. Classification on the basis of the type of backbone chain. We have organic polymers. The backbone is carbon backbone rather. Organic polymers play a crucial role in living things, providing basic structural materials and participating in vital life processes. For example, the solid parts of all plants are made up of polymers. These include cellulose, lignin, and various resins. Cellulose is a polysaccharide. Cellulose is a polysaccharide, a polymer that is composed of sugar molecules. Lignin consists of a complicated three-dimensional network of polymers. Wood resins are polymers of a simple hydrocarbon, isoprene. Another familiar isoprene polymer is rubber. While the second one is inorganic polymers. The backbone constituted by elements other than carbon. Inorganic polymers. The backbone constituted by elements other than carbon. Polynucleotides, chain of deoxyribonucleic acid, DNA. Other important natural polymers include the proteins, which are polymers of amino acids, nucleic acids, which are polymers of nucleotides complex. Sorry, let me take that again. Nucleic acids, which are polymers of nucleotides complex molecules composed of nitrogen-containing bases, sugars, and phosphoric acid. The nucleic acids carry genetic information in the cell. Starches, important sources of food energy derived from plants and natural polymers composed of glucose. Now, this is a table that shows some examples of monomers and the polymers. We have the monomer name is propene. Then the monomer structure, we have 3 carbon atoms here with double bond in between, and the name is propene. This is a monomer. Then the polymer is polypropene. Polypropene, and this is how the structure is written. You can see that there is a break in the double bond here, showing that the structure is a polymer. And this N signifies that the number of propene that aggregate to form polymer ranges from 100 to thousands. Then the second one, we have propyl-nitrile. This propyl-nitrile, the addition of double bond to propene is what do you call it? Acrylonitrile. Let me take that again. Sorry for that mix up. The second one is propyl-nitrile. The functional group cyanide attached to ethene gives a monomer called propyl-nitrile, and the polymer is called polypropyl-nitrile. Polypropyl-nitrile, also known as acrylic. Now, this is the structure of that polymer, the polymer that formed from propyl-nitrile. And of course, there must be N. This N signifies numbers of or several units of propyl-nitrile that come together or aggregate together to form a polypropyl-nitrile. And there must be a breakage in the pi bond. You can see the double bond here, and there's no double bond here. This double bond here is splitted or separated to form this bond here and this one. And so this bond forms the basis of the aggregate where or pave way for another unit, another propyl-nitrile unit to attach. And this continues. And when you have a number of these propyl-nitrile, let's say 50 or 100 coming together to form a polypropyl-nitrile, then the name polymer or polypropyl-nitrile comes into play. The reason is because the N here signifies from 2, 3, 4, 5. It could be, in fact, it can range up to thousands of these monomers for this polymer to be formed. Then we have another monomer called phenylethene. This is phenylethene. This phenylethene is a monomer forming thousands of phenylethene come together or aggregate together to form a polyphenylethene, also known as polystyrene. The second name of polyphenylethene is called polystyrene, where you have different units of phenylethene or polystyrene come together to form this compound or this polymer known as polyphenylethene. Now, with this, we come to the end of this class, and we are going to be looking at the details of the reaction, how addition reaction or addition polymerization occur, and also the condensation reaction, and we are going to be looking at the catalysts involved in forming some of these polymers. And we are going to be looking at that in our next class. Thank you for listening. And I believe you are going to do justice to this course. Go and download the course as you go through, and don't limit yourself with this material. Go out there, search for other materials, and update yourself. Thank you for good listening.